Hey, what is going on, everyone? Welcome to another video. Today, we're going to be talking about everything graphing inequalities. So this is going to start with a gold homework assignment where you are just graphing one inequality, which if you can graph lines, you're already like 95% of the way there. If you're struggling with graphing lines, maybe go back to the previous video about graphing lines, or come in and talk to me and we can work through how we can help you improve on that skill. But that's going to be the necessary skill is, can you graph lines? The other thing is, can you think? Now, I know some of you might be sitting there afraid, but I have faith in every single one of you. Everyone can learn how to do this. All it takes is a little bit of time and effort. So first things first is, we just need to graph one inequality. Before we can make a system of inequalities, we have to graph one. So let's do our first one as y is less than, I don't like that pen size, y is less than or equal to x plus 5. Now maybe the first thing we want to think about is, well, what is this new symbol? Maybe this is new to us, we haven't seen it, or maybe we just haven't seen it in a while. So when we see this, we want to think about this as it is less than, which means whatever is the bigger thing goes over here, and this thing is smaller. And that's really important, is to remember that no matter what, that is the case. Whatever's on the open side is bigger. Now, that means you could rewrite this thing as being x plus 5 is greater than or equal to y. Or you could say that y is less than or equal to x plus 5. Both of those mean exactly the same thing. That's the flipping thing that we can do on equalities. We just have to flip it and we don't have to change the equality because the equal sign is the same, whereas these symbols are relative to what's on each side. So when we're dealing with this, we first off need to also remember or. If we're talking about maybe going out and getting some food, that maybe I'm like, you know what, I want Chick-fil-A or Taqueria Picaro, which is up in Ashland. It's a great Mexican restaurant, very authentic, but still like not overly spicy in my opinion, because I can't do spicy that much. But, or, I want Chick-fil-A or Taqueria Picaro. If you choose one or the other, I don't care. You can choose Chick-fil-A. I'll be just as happy as if you choose Taqueria Picaro, which that's what or does. And we use or a lot. In the English language, we tend to use or both as the strict or, which would be like if you have A or B. We mean it a lot of the time as being, oh, you could choose A and B, or you could choose B. Any of these are all viable. Mathematically speaking, later on, there is also a or, and this is a strict or. You kind of learn the difference later. They'll say strictly this or that. But what that means is a strict or means you can be A or B. There is no middle ground. But in this case, we care about that, both of them. So just keep that in the back of your mind. You might get a strictly or sometimes, but it's not very often. Now, we're looking at this thing. We want to graph it. Pretend like this is just equals to start. Since there is an equals sign here, that means we're going to be graphing a solid line. So just treat this like a regular line that you graph. And I'm going to go pretty fast through this, so if you need me to slow down, come into class and we can talk about it. But we're going to start at 5. And we're going to go up 1 over 1. And connect our lines and hope that that line goes perfect. So now we have our line graphed. Now all that's left is to think about it. So if I pick a point, like in this case, I'm going to pick the point 0, 5. Over 0, up 5, the y-intercept of this. If I plug this in, do I get a true statement? Is 5 less than or equal to 0 plus 5? Well, 0 plus anything is just that thing, so 5 is less than or equal to 5. Is that true? Yeah, 5 is in fact equal to 5. But that means that everything on this line here is then included. That's why it's a solid line, because every value here satisfies this statement. Now, are there other points that satisfy this statement as well? Well, let's see. What if I pick a point just at random? I'm just going to pick 0, 0. And the reason you'll notice on any of these examples, if you watch me do them, and I'm plugging in a point, I'm going to plug in 0, 0. And you can plug in as many points as it takes for you to believe the side that should be shaded. I like to just choose 0, 0. If it's true, I color towards it. If it's false, I don't. I color the opposite way. So if 0, 0 is true, I'm going to be shaded over here. If it's false, I'm going to shade over here. Either way, I only have to plug in 1 point once I feel confident. So if I plug in 0, 0, is 0 less than or equal to 0 plus 5? Or is 0 less than or equal to 5? Give you a moment to whip out your little line chart. 0, 1, 2, 3, 4, 5. I went to the right. Yes, it is in fact true. Which means I'm then going to color with the smallest highlighter tip I could have asked for. But no worries, we can make it work. But here we are. That is everything that makes this true. That means that any point you choose on this side of the line works. It satisfies it. And honestly, what I would recommend is right now, pause the video. I would go work through the gold sheet and the front of the green sheet and see if maybe you notice a pattern. I'm going to give you a moment to pause and go work on that. So now, kind of just the trick here is whenever you have this lined up, so if you have written y is whatever in relation to the line that you have to graph, you don't need to plug in a point. You can if you're like, I don't believe it, I still think that that's not true. Keep doing it. Plug it in. See why it works. Get enough examples that you're like, yes, I believe it. I believe that you could just decide based on 1 point. I'm going to tell you, you can decide on even less. When you have this equation, if you have y on one side and the other things on the other, if you have kind of this arrow pointing towards the y and it's open towards the other stuff, you're going to color down from your line. So if you pick a point, like right here, we're less than, you color down because this is all the y values less than our equation value. If it's open towards the y, you go to any point and you color up. And you'll get faster at that. You're going to just start seeing these and you're going to see kind of the general graph in your head. Because right now, a lot of you might be sitting there like, I don't see it yet. Don't worry. You're going to get lots of practice going through all of the assignments. And it's just something that you get better at as you do it. And that's the way with everything in math. Math is a very practice-heavy topic. That it's like any sport, in my opinion. And that's why I love it. It's because you could be naturally horrible at math, and yet you could work your way to being better at it than anyone who was just born naturally gifted at it. And in fact, those are the better mathematicians in the long run. But this is kind of the generic graphing one linear inequality. Now, what I want to do real quick is just change up what we're doing a smidge, just kind of a little detour. I'm going to copy this because I don't want to redraw too much if I can avoid it. What changes if we're graphing y is just strictly less than x plus 5? Well, a little bit's going to change. We're going to only really be changing one little detail, but it's important. So when we go to graph our line, we need to think about, does the point 0, 5 satisfy this statement? Because that still should be the y-intercept according to everything we know about y equals mx plus b form. Let's see. Is 5 less than 0 plus 5? is 5 less than 5? Maybe ask yourself this. Are you less than yourself? Hopefully your answer is no, you're not. You are in fact equal to yourself. So this is not a true statement. This is false. So since that is false, what this tells us is that any point that's on the line, in air quotes there, any point that's on that line doesn't satisfy it, which means we can't have solid coloring. That when you're thinking about this line over here, this shading below should really be the same darkness as our line. There should be nothing but just dark, bright blue over on this side. So when we're looking at this, that means the points on this line cannot be solidly colored. So we use a dotted line. And it's a lot easier if you're doing this on paper with a ruler, just knock it down. But then everything else is exactly the same, except for I'm going to use a thicker one. That's more like it. Not only is it faster, it actually gets good coverage. So that's the only difference here when you're dealing with this sort of inequality, is that the line's dotted. That's it. That's the only difference. Now, you can take a minute, pause right now, go work on the gold and the green sheet, then come back, and what we're going to do is we're going to start going through kind of the buff sheet, but I'm going to be doing an example working through number 3 on the yellow sheet. It's from that yellow packet you got. It is Introducing Technology to Inequalities. We're going to work through number 3. So I'm going to scroll down here, paste this. This was our y is less than or equal to x plus 5. Next up, I'm going to be graphing, throwing in here in pink, y is greater than or equal to x. So first up, what we're going to do is, for right this second, I'm going to leave the shading. I'm going to not touch anything else about this equation. I'm only going to add my new line. So we have our solid line. This one, y equals x, is a really common line. We're going to use it a lot, especially when we start getting into anytime you're dealing with inverse functions, which I think we're going to cover a little bit. Maybe that's a pre-calc topic for you, but this line is really important, and it's really simple. Just think about, what is it saying? Y equals x. If my y value is 2, what's x? Well, y equals x. 2 equals 2. Okay, let's try a different point. So maybe we have 2, 2 there. Let's try a different point. 5 equals 5. And hopefully you're starting to see this pattern. If not, come in and we can talk about it. Right there. Y equals x is just a 45-degree angle that splits quadrants 1 and 3 in half. So now the question is, okay, my blue equation, we can see it's colored below. And you'll notice on any of my answer keys that you're looking at that I put these little arrows out at the end. First off, always extend the lines you're graphing off of your graph. If you have a grid here, I want to see it off of that grid. Because then you can come in and you can put these little matching arrows to it that shows you, okay, that line I'm coloring down. And this line, the pink line, okay, y is greater. Okay, well, our little trick was y is greater means you color up from any point on the line. So if I pick this point, I'm going to color up. And that's what this little arrow over here is telling me. So now, what that means is I need to look at my regions. So I have kind of region 1, region 2, and region 3. Are the points in region 1, if I pick a point, say right here, is this point below the blue line? No, that is not. 5, 1, 2, 3. What if I pick a point right here? Is this point above the pink line? No, it's not. So these two areas, here and here, should not be colored. So let me go ahead, get rid of that. What about a point right here? Is this point below the blue line? Yeah, it is. Is that point above the pink line? Yeah, it is. So what this tells us is that that area between these two lines, and let me find a good color. Maybe let's go black, because that's going to be kind of between everything we're doing. So everything between these two lines in this case should be shaded. And what this means is that any point that's either on one of these lines or between them satisfies both equations. That means that if you pick any point here, say the point 0, 0, 0, 0 satisfies both of these. 0, 5 satisfies both of these. So that is really important, is that anything in this shaded region, the shaded region is the set of all points which satisfy the system. The shaded region is the set of all points which satisfies the system. Really important to keep in mind there. So now we've graphed two inequalities. At this point, you could work on the buff sheet and the first, I believe, 6 problems of the salmon sheet. It's just graphing two linear inequalities. But now let's go ahead and let's just mix it up. Let's add another one, because why not? Why not just add it? Because when you think about life, how many times in life do you have just 2 restrictions on you? Let's think about legally. You decide that you want to do anything in the US. It's worse other countries. It's far better here. But just about anything you decide to do, there are restrictions on what you can do. There are government people who are going to tell you, hey, you can't do that because of XYZ. So it doesn't make sense for us to only talk about, oh, there's 2 restrictions. Well, a lot of times in life, there's 3 restrictions, 4 restrictions, 5 restrictions, 6, 7, 8. Goes on forever. There's almost infinitely many. There's innumerably or countably infinite number of things limiting you in life. But we're going to stop at like 4 or 5. Because most of the time, the situations that we're dealing with as human beings, we can really only think about like 5 things limiting us at a time before we need a computer to start kind of augmenting and helping us through that. But if you know how to do, if you know how to do 4 inequalities, you could set one of these up for anything in your life and be good. And you could figure it out. I believe in any of you to do it. So that's what we're going to move towards. We're going to throw one more inequality on this. Let's find, I'm going to go with green. So let's add one more equation here. Let's add the equation x is greater than or equal to -3. Okay, first off, is there a y in this statement? X is greater than or equal to -3. If the answer is no, there is not a y, there should be zero, or not zero, there should be no slope. You should not be a 0 slope like this, and you should not be angled in any way, because these all require that you have y equals something. If the slope is 0, y equals a number. If it's angled at all, y equals some number times x. In this case, there is no y, which means that this is a straight up and down vertical line. And it happens when you're at -3 on the x-axis. So what you're going to do is come here to -3, draw your line in, And the beauties of technology is I can adjust my line even though it wasn't perfect. Now, x is greater than or equal to -3. Which way am I going to color? Pause for a second. Think about it. Get an answer. Am I going to color left or right? So, hopefully you're sitting there, okay. If I'm on the x-axis, I have 0. I have 0. If I want to get bigger, I'm going to go towards this positive x. I don't want to go towards negative x. I want to go towards positive x. So anything this direction is colored. So I'm going to put my little arrows up here. And now I'm going to get rid of this. Oh no, too much. I'm going to get rid of that. And now I want to ask, okay, now I have a lot more regions. I have this region, that one, this one. That's all one. This one and that one. There's a lot more regions now. It's starting to get a little more confusing. But let's look at this. Let's think about it. Okay, before we knew, all of this stuff was colored in. So I already kind of have a restriction. I already know that, like, I'm not going to color out here. I already know that. So just looking at this stuff here, which part of this little highlighted red section is to the right of the green line? Well, yeah, it has to be. Get my highlighter out. All of this stuff here. And now we've restricted this down even more. That we could pick any point in here and we can go out to infinity and we have this infinite number of points in here because it goes on forever. There is no end. This is all theoretical stuff. Let's add one more equation. Let's block this shape up. I'm going to go with my red here and just a quick little detour. If you have y plus 2x is less than or equal to 5. We don't like graphing that in that form. We want y all by itself. To solve for it, just move the 2x over to the other side by subtracting it, so y is less than or equal to negative 2x plus 5. So, once again, it's just graphing a line. And that just takes practice. So, plus 5, I'm going to go down 2 over 1 and come in and connect my dots like so. And y is less than, which means I'm coloring below this line. So are the points over here? So is this point below this point? No, it's above it, which means this region here is false. So clear that out, get our highlighter back in here, and now we have this shaded region here. And that is what we call the feasible region. The feasible region is the shaded region. So that is how we graph multiple inequalities, how we graph what we call a system of inequalities, where any point in here is a solution to all 4 equations in this case. Now, something that becomes really important is what do we do when we want to find these corners? And these corners are important because, well, anything in here is a solution. All the things inside are not the best solution. But like when you think about what you're doing in life, like say you want to buy a car. If you want to buy a car, you have some restrictions. Like for me, I'm looking at getting one here in a couple of years, getting a new one to tow stuff. Well, I want to be able to tow the things that my wife is going to want. I want to be able to get good gas mileage because I don't think gas prices are coming back down for at least 3 or 4 more years, if ever. I want to have a nice stereo system. I don't want to pay too much for the car. I want leather seats. I want a cool color. I want all of these things. I could give you a long list, but at the end of the day, the chances are I'm not going to get all those things because, say for me, I love Toyotas. If I were looking at a truck back a few years ago, the color I love is it's called their Voodoo Blue. It's beautiful. It's this bright blue. It only came on the Pro model, which I want to say the truck payment on the Pro model was like $700 or $800 a month. You can look up what a teacher makes. You can look up exactly what your teachers at Medford make. That's way too much money. I can't afford that. So I have to sacrifice the color in order to meet the requirement for my budget. I can't afford a $700 payment. I need something more like that. Really, ideally, I'd love like a $200 payment, but probably a $300 payment is more where I'm going to be whenever I am making this decision. So I had to sacrifice one thing. I had to sacrifice one of these requirements in order to get this one, which is maximizing my pink equation and my red equation. So that's what this solving for the corners does. Now, if you have the calculator, you can go watch the video that I went through how to do that in the previous video. If you don't have a calculator, you're still not stuck. We just need to think about, okay, we have 4 corners. We have 4 equations. When we have the graph, it's really a lot easier to see this. That, okay, this one is the pink equation and the red equation. So pink equation, I'm just going to write it because these are equals for all we care about. Let me give myself a little corner here. I want the pink equation and I want the red equation. Y is equal to negative 2x plus 5. So I want to know where these two things equal. Well, I have y equals x and y equals negative 2x plus 5. Why don't I just substitute? I can replace y with x in that second equation. So I have that x equals negative 2x plus 5. Well, let's just solve for x. Get all the x's on one side, all the numbers on the other. I have one statement and one variable. Add 2x, I get 3x equals 5. And I get that x is 5/3. Now I'm just going to plug that into one of my equations. Now, we always want to work smarter, not harder. Y equals x. Ding. One of my points is 5/3. 5/3, and in fact, it is this point here. Now you can go through and solve for this one if you want more practice. You can come in and talk to me and you can double check it. But hopefully when you solve for this point, so that's the blue equation and the red equation, hopefully you just see it very quickly what that point is. Some points are given to you because of the information that you're given in the equations. Others are just given to you by logic. Like this point here, the blue and green equations. So I have x equals negative 3 and y equals x plus 5. All right, substitute in. X is negative 3 means that I have y equals negative 3 plus 5. Y equals 2. So one of my other points is negative 3, comma 2. It's right there. So this is kind of the last skill that you need, is being able to find those vertices. Once you can do that, you are pretty much set. Then the only skill that you really have, if you can answer all of the questions on the yellow packet, introducing technology to inequalities and practice makes permanent, you're good for the first 2/3 of the test. The last page is the next thing that we're doing, which is linear programming, which is working through a problem where you're given a life situation and you have to make the inequalities. So make sure, do all your homework, get the practice work done. Any quizzes or homework have to be taken care of before the test. If you took one of the quizzes and you're like, I don't like my score, don't worry about it. We're going to be handling that a little differently on this test. So what's happening on that is you're going to have opportunity on the test. There happens to be questions that line up perfectly that were on your quiz, that were basically on your test. If you can prove to me that you know how to do it on your test, then congratulations. I'm going to change your grade. I'm going to bump it up. Otherwise, we're going to work on it, and you're going to prove to me that you understand the problems, that you understand the math, and aren't just regurgitating it. So if you have any questions, please stop by. I am in my room all the time. You're welcome to come in. I'm here. If the lights are on, you're just about always welcome unless I'm in a meeting. But usually I'll try to let you know about that. So hope you have a great day. If you have any questions, please come in and ask, and I will see you in class.